Don't just play Saturn classics on your MiSTer, feel them. Get yourself a Daemonbite adapter, cheap, easy, and responsive.
Hey guys, welcome back to the channel. My name is Nick and today we're going to be building a Daemonbite adapter for MiSTer FPGA so you can use your favorite OEM Sega Saturn controller for that old school nostalgic feel. Daemonbite adapters are great because you can build them for a reasonable price and they work great with MiSTer with super low latency around a millisecond. You do need some soldering skills to assemble these though, but if you follow this guide, you'll be up and running in no time. I'll also be releasing guides for NES, SNES, N64, and Sega Genesis adapters soon, so make sure to subscribe and turn on notifications so you know when those guides go live. I've also designed and 3D printed my own adapter case for this project. Like this video if you're interested in using this case for one of your adapters. Alright, so let's get into it. Here you can see all of the parts that we're going to be using for this build. First, we need to use an Arduino Pro Micro for this project. In this case, I happen to have one that can be used for 3.3 volts or 5 volts. More on that later. I also chose to go with a USB-C version in this case. We're going to be using a replacement Sega Saturn controller port for this project. You can often find these on websites like AliExpress. I chose to go with some 22 gauge wire for this project. I only had 6 colors on hand though, so a couple of colors will be used more than once. Since we 3D printed our own case and are using threaded brass inserts in this case, we're going to use 12mm M3 hex screws to fasten the case together. Next, I decided to use an M1.4 by 5mm machine screw to fasten the Arduino board securely inside the case. If you don't have access to a 3D printer to house the Arduino, you can still build this adapter. I just recommend using electrical tape or even Kapton tape to wrap everything up once you're done to make sure that you protect all the electrical components. Last but not least is the custom case I designed and 3D printed for this adapter. Don't forget to check out my printables page for the files to download if you want to print it yourself. You can also find my other adapter cases there as well, link in the description. We're going to cut 9 wire lengths of 50mm to connect the Arduino to the controller port. I chose to cut 1 length of black, 1 length of red, 2 of white, 2 of blue, 2 of green, and 1 of yellow. You can choose whatever colors you like, but all the instructions and diagrams in this video will reference this color scheme. Strip about 1/8 of an inch or 2 to 3 millimeters of insulation off both ends of each wire. There are a lot of wires for this controller adapter, so a lot of processes need to be repeated. I didn't want any steps to be skipped over, so I'm just going to speed up the video here and there as a result. We're going to tin both ends of each wire with solder, so gently grab the bare wires and twist to make sure all strands get tightly wound together. Okay, fire up the old soldering iron and lightly tin both ends of each wire with solder. Make sure the wires are coated well, but don't glob on a bunch of extra solder. The reason you don't want too much solder here is because if you do, you won't be able to fit the wires through the vias on the Arduino board very well, and also it might be more difficult to attach the wires to the controller port later. Alright, we're done tinning the last wire. Now what we need to do is start prepping the Arduino itself. You need to solder the J1 jumper. This ensures that the Arduino gets 5 volts of power from the USB port. Next, we're going to pre-fill 9 vias on the Arduino with solder. You can see which vias are being filled in the diagram on screen. I have also included another diagram which shows where the wires from the Arduino will connect to the controller port. Now that the vias are filled with solder, we're going to insert the wires into each via. Since we filled each via previously, we're going to use the tip of our soldering iron to heat the solder in the via from the rear of the board and gently push in the wire from the top side. Again, you can reference the color-coded wiring diagram on screen to see exactly where I connected each wire. As I mentioned earlier in the video, I only had 6 different colors, so there's a little bit of duplication in the wire colors here. If you follow this color scheme, just make sure you pay careful attention to my diagrams. You can use any colors that you like, but make sure that you connect them appropriately to the controller connector later. Okay, let's prep the controller port. Lightly tin each of the 9 solder pads on the top rear section of the controller port. These pads are small, so be careful with the tip of your soldering iron so that you don't accidentally melt any of the plastic on the controller port. Follow the diagrams on screen to make sure you solder each wire from the Arduino to the correct solder pad at the rear of the controller port. Notice the diagram on screen identifies the solder pads looking at the top of the controller port. Also note that pin 1 is on the left side in this orientation. Do not get the wires reversed. You should be able to heat up the pre-tinned pins on the controller port and slide in your pre-tinned wires from the Arduino right into place. In this tutorial, we're soldering the wires in from pin 1 to pin 9 consecutively. Again, there are a lot of wires here and potentially some similar colors, so it's best to double check every connection. It's easy to get a little bit mixed up if you're flipping the port around to access connections from all different angles. Trust me. Just a few more wires to go. Sit back and enjoy the tunes. We'll be back momentarily to install the board into our 3D printed case. Okay, grab the bottom half of the enclosure and insert the USB connector of the Arduino into the case cutout for the USB port. It's a snug fit, but push the Arduino board down into the case and fasten it into place with the M1.4 screw. You can put the screw into via 9 or 10 of the Arduino board. It won't damage the Arduino. Next, insert the controller port into the slot at the front of the case and drop the top side of the enclosure into place. Finally, insert the M3 hex screws into the 4 screw holes on the bottom of the case and tighten them up snug. And that's it, the adapter is finished. Now all we need to do is flash the Arduino and it'll be ready to plug into the MiSTer. Plug in your USB-C cable to the adapter and to the PC and we'll move over to the PC. Go to the MacGyver Daemonbite GitHub page to download the zip file that we'll be using to program the Arduino. Link for the GitHub site will be in the description below. Extract the zip file and open the folder you created. Open the Saturn Controller USB folder and double-click on the Saturn Controller USB.ini file. The Arduino IDE program will open. If you don't have it installed, a link will be in the description. Navigate to the Tools menu and go down to the Board submenu. Select the Arduino AVR boards option and then select Arduino Leonardo. Next, go to the Tools menu again and navigate to the Port submenu. From here, select your Arduino Pro Micro from the list. In my case, mine was on port number 10. Press the right arrow button in the menu bar to proceed with the upload to the Arduino. In the bottom right hand corner of the window, you should see that the data is compiling and then being uploaded to the Arduino. If everything goes to plan, you should get a Windows notification pop up that says your Arduino Leonardo device is ready in Windows. Open the Run command in Windows by pressing the Windows key plus R. Then enter the command joy.cpl. Select your Arduino Leonardo device from the Game Controllers window and choose the Properties option. You should then see a new window open with a visual display of your button presses. Press all the buttons on the controller and the D-pad to make sure that everything is working properly. If all your inputs are reading properly, the adapter is finally finished and ready to be used with your MiSTer. Okay, now that the adapter is built and functioning, let's go over the pros and the cons. First, the pros. Number 1, components are reasonably priced. Number 2, low latency. It's not as fast as Snack, but it's really low. Number 3, you can flash the Arduino for use with 1 or 2 controllers. Number 4, you can connect to standard MiSTer USB ports. You're not relegated to the user port like you are with Snack. Number 5, this is a big one for some people. You can navigate the MiSTer menus. You cannot do this with Snack, but you can with Daemonbite adapters. Number 6, as an added bonus, you could use this adapter on a PC if you wanted to. And now for the cons. Number 1, this is a DIY project and it does require assembly and some knowledge of soldering. Number 2, you do have to source your own parts and availability could be tricky depending on which websites you check. Number 3, it's not zero latency. This is not Snack. If you need zero latency, it's not for you, but honestly, it's so low it's not even an issue for casual players or even for mini speedrunners. That's the Sega Saturn Daemonbite adapter for MiSTer FPGA. Use your OEM controller for that nostalgic retro feel, but on modern hardware. As I mentioned earlier, I'll be adding new videos soon, guys, for NES, SNES, N64, and Sega Genesis adapters. Keep an eye out for those, so make sure you get subscribed. But what do you think? Would you build a Daemonbite adapter for your MiSTer, or just use a USB controller, or maybe even just go wireless? Let me know in the comments below. I'm curious what your preference is. If you enjoyed this video, drop a like and don't forget to share. It helps me out so much. I also stream tons of retro content on YouTube and on Twitch, so stop by sometime and say hi. As always, guys, thanks for watching, and I'll catch you in the next video.